Welcome to Mathematics. Today we're gonna do the integral of inverse sine of ln(x) from 1 to e. And to do this integral first, we're gonna use up let u is equal to ln(x), so we can raise e on one side, e to the u is equal to x. So differentiate both sides, you will get e to the u du is equal to dx. So, and then we're gonna put 1 inside, you will get 0. Put e inside ln(x), you get 1, and then e to the u multiplied by the inverse sine of, and then u. E to the u times inverse sine u du. And how can we integrate this? We're gonna use our DI method. We're gonna differentiate inverse sine u and then integrate e to the u. Keep integrate, you get e to the u, and then differentiate inverse sine u, get 1 over square root of 1 minus u square, and then this time that you get e to the u times inverse sine u, and then don't forget about the lower limit and then upper limit, and then we're going to subtract integral of e to the u over square root of 1 minus u square du from 0 to 1. And here, this is really easy, just put 1 here, inverse sine of 1, you will get pi over 2, and then e times pi over 2, you will get e pi over 2. And then minus, and then 0. Put 0 over, you just get 0, so it doesn't really matter. And then here, we're gonna use our trisub. Let u is equal to sine x, sine theta. Or you can use cosine theta, and up to you. And then u is equal to sine theta, and then du is equal to cosine theta. We like to use sine theta because we don't want negative here. We don't want a negative, so positive. Differentiate sine theta, you get a positive. So here, what's our theta gonna get? Theta is equal to inverse sine u. Inverse sine 0 is just 0. Inverse sine 1, you get pi over 2. Then e to the u over square root of 1 minus, and then u is sine square theta, and then multiply by cosine theta. And then here, 1 minus sine square theta is just cosine square theta. Take a square root, you get cosine theta, and then this and this, you cancel each other, so you can get e times pi over 2 minus the integral of, I forget to change it to sine theta, sorry. It's the integral of e to the power of sine theta d theta. And what is this answers? If you plot these answers plus this integral on Wolfram alpha, you're gonna get minus, and here is it. The integral of e to the power of sine x from 0 to pi over 2, you get this pi over 2, 1 over 2 pi, and then L0 of 1. L0 is a modified Bessel function of the first kind, and the ln of x, not the L, this I of n, in, and this ln, big letter L, and n is just a constant here. And big letter L, I will put this as big letter L. Big letter ln is the modified Schwarzschild function, and this is the Bessel function. I like to call this as Bessel function, and this is Schwarzschild function. And I will introduce to you on my later video. So this is just, let me just distribute it. So you get pi over 2 times L0 of 1 plus pi over 2 I0 of 1. So the answers to this integral is just e power of pi over 2. No, e times pi, not e to the power of pi power. E pi over 2 minus pi over 2 L0 of 1 minus pi over 2 I0 of 1. And that's our answers. And this is about to be 7.37. 4 to 5. So this is a really interesting integral. And if this is a indefinite integral, you don't have answers to this e to the power of psi theta. But I just randomly type this integral and it's giving me this answer. Really weird. Don't worry, I will introduce to you this function on my future video, and peace out.